Hi guys, in this video we are going to look at Identities grade 11. So we are working with proofs, trigonometric proofs. Right. For you to tackle proof, guys, it is vital or it is important to know identities. So the first identity that you must put in your mind is sine squared plus cos squared theta, which is equals to 1. From this identity, we can have two identities. Consider we make sine squared theta a subject. We are going to have 1 minus cos squared theta. So let's say we make cos. So it's going to be cos squared theta, which is equals to 1 minus sine squared theta. Then we have what we call a quotient identity, which is tan theta, in which you are going to always change it to sine all over cos theta. Sine theta all over cos theta. So these are the two most important identities, especially when you're working with proofs in grade 11. Consider we are given this proof here. It's 1 all over tan squared minus cos squared, which is equals to cos to the power of 4x divided by sine squared x. First thing first, we're working with a fraction. Whenever there's minus or plus, it is important to find an LCD because remember, these are unlike denominator. So find an LCD. So what will be the LCD in this case? The LCD will be tan squared x. Some of you may ask yourself why I'm saying tan squared. Remember that there is invisible divisible 1 here. 1 times tan squared x is the same as tan squared x. So from there, remember we're working with the left hand side. We want to prove that it is equal to the right hand side. So let's place, we are going to place the denominator, tan squared x. Then from there, remember it's the same as 1 all over. This is the same as cos squared all over 1. Then we are going to use a cross method. 1 times 1, that will be 1. And tan squared times x, tan squared times cos, it's going to be tan squared x multiplied by cos squared x. Okay. Guess this is the denominator. So let's work it out. From here, we can change tan since it's a quotient identity. Remember I told you that when you change tan, it's going to be sine all over cos. So in this case, it's going to be sine squared divided by cos squared x multiplied by cos squared x. So in this case, we are allowed to cancel. Remember, we have tan squared x. So this and this, they cancel. Remember that we are left with sine squared x there. So we'll be left with 1 minus sine squared x, okay, divided by cos squared x. Sorry for that, not cos, divided by tan squared x. So let's consider this. What is 1 minus sine squared x? Remember I told you that when it's 1 minus sine squared x, it's the same as cos squared x. So in this case, we are going to say cos squared x divided by tan squared x. So we need to change tan since tan it's a quotient identity. So what are we going to do? We are having cos squared x. In other words, let's say divided by sine squared x all over cos squared x. So to get rid of this, we need to use its inverse. So it's cos squared x multiply by cos squared x divided by sine squared x. Okay, so let's continue further. Cos squared times cos squared is cos to the power of 4x. Cos to the power of 4x divided by sine squared x. Remember, there's invisible 1. 1 times sine squared x is the same as sine squared x. Hence, we have proven that the left-hand side is equals to the right-hand side. So that's how, guys, you can prove the first question. That's how you can work out with the first question. Right. We saw that it is very important to find an LCD whenever the denominators are unlike. Remember, when the denominators are the same, we add this numerator or subtract, right? Depending on the given operation that we are given. Right. Let's go to the second question of our video. We are given 1 all over cos theta minus cos theta divided by 1 plus sine theta. So here we are required to prove, right? So since we have unlike denominators, remember what I told you? When we have unlike denominators, it is important to find an LCD. So LCD will be cos theta multiplied by 1 plus sine theta. Okay, so we are working with the left hand side. We need to state. So under denominator, we are going to put cos theta 1 plus sine theta. Okay, so we can use a cross multiply. Okay, 1 times this will be 1 multiplied by 1 plus sine theta. Okay, cos times cos theta times cos theta. 1 times 1 is going to be 1 plus sine theta. Cos times cos, remember there's minus here. Cos times cos, it's cos squared theta. And we have cos theta as well as 1 plus sine theta. Okay. So let's work out the denominator. So we could see that we can see that we have a square identity there, which is 1 minus cos squared theta plus sine theta then. Okay, we just arrange there. Therefore, it's cos theta plus 1 plus sine theta. Okay. Right. What is 1 minus cos squared theta? Go back to your identities. 1 minus cos squared theta, it's the same as saying it's equals to sine squared theta. That's what it means. So 1 minus cos squared theta, it's the same as sine squared theta plus sine theta divided by cos theta, open the bracket, 1 plus sine theta. Okay, so from here we can take out the highest common factor. The highest common factor is sine theta. We are left with 1. We are left with sine theta. Sorry for that. Plus, to get to sine theta, we need 1 plus 1. Okay, divided by cos theta, which is the same as 1 plus sine theta. So what is happening? This thing and this thing is the same because this is the same as a commutative property. When you have 1 plus 2, it's the same as having 2 plus 1. So 1 plus sine theta is the same as sine theta plus 1. It's a matter of arrangement, but it's the same thing. So what we could do, we can cancel this. Then we're left with sine theta all over cos theta. Then sine theta all over cos theta, it's tan theta. Hence, the left-hand side is now equal to the right-hand side. Remember, innocent until proven guilty. That's the technique, right? You must have knowledge of fractions, know well your identities, know when to change, and know when to cancel. Hope you find this video useful as you're preparing for your June examination. If you're new to this channel, what are you waiting for? Let's do the right thing. Let's subscribe. You only subscribe once. Right. See you on the next video where we are going to talk about general solution. We love you.